All right, so lads and ladies, let's have a look at this back question from last year's back, right? Now, this is one that caught people, a lot of people, I'd say, right? Because it looks more complicated than it actually is. So let's have a look at it and see if we can break it down a small bit, right? Now, I'm asked to consider the functions f and g defined for x greater than 0. We've got an f of x is equal to root x and we have a g of x is equal to ln of x, all right? Now, below, we're showing the two of them in a picture just there, right? And I'm showing a dotted vertical line from a point on the graph of f to a point on the graph of g. Now, that dotted line was actually kind of a bit of a hint, but I think a few people didn't really notice it. Now, I'm being asked to determine the minimum vertical distance between the graphs. Okay, now, if you want to head off and try to solve that all on your own, pause the video now and away you go. Otherwise, I'm going to lash into a bit of an explanation. I'll start off with some hints and then we'll get into the full correction. So, now, here's the thing, right? We're looking for a minimum. Wherever I see the word minimum, as soon as I see that word, I'm going to go, okay, I'm definitely going to be differentiating here, right? If I'm looking for a minimum, I'm looking for the derivative equal to 0. So that's the first thing. What am I going to be deriving though? And here's where, if I asked you, right? Because I asked you what's the minimum difference? And you go, Jesus, what am I doing here at all? If I said, and that's where I say this dotted line was actually a hint. If I said, look, let's let x is equal to, say, 7 and find me the minimum distance between f and g, you'd probably know what to do next, right? Now, again, if that's given you enough of a hint to go away and solve the question on your own, tear on there and I will crack on in 3, 2, 1. Let's go. Right, so I'm just going to go, if I was looking for the difference between the two graphs, at x equal to 7, well, then I do f of 7 minus g of 7. All right, I know f is up on the top and I know g is down below. All right, so I do f of 7 minus g of 7, and that would give me the distance between the two, the f value being the y value right over here. So that'd be the f of the g taken away from the f of the, no, would you stop being silly? So that would be the g of 7 being taken away from the f of 7, and happy days. It would give me this distance, which would be the distance between the two graphs. Lovely. Now it was for a specific point, and this is that was a bit of a hint there. Like quite often, I will use a specific point to kind of get an idea what I'm doing in the general sense. So what did you do in order to find distance? The distance, all right, any distance between f and g will be given to me by f of x minus g of x. So that's an expression for the difference in height between them at any moment in time, okay? So let's just start calling that d, all right? So d is equal to f of x, we said, so root of x minus g of x, so minus ln of x. All right, so far, so easy actually at the end of all that. Now, if I want to find that minimum distance, I want to find at what value of x that happens. Look, I'm going to find d dash of x. All right, that's going to be given to me. So root of x is x to the power of a half. So that I'd multiply the x by the power. So that would be a half x. Diminish the power by 1, and that would be minus x to the power of minus a half there. So, and ln x, when I derive ln, it ends up being, that would be minus, so 1 over x. Okay, that's available in your formula sheet, so you don't even need to be messing around with anything else. So this is the distance. This will be, sorry, I'm using this. I want to now, right? Sorry, my brain is not braining. Okay, so what I want to do is I want to actually solve d prime of x equal to 0. So now I'm looking to solve a half x to the minus a half minus 1 over x is equal to 0. All right? And how am I going to go about doing that? So in order to do that now, I'm going to get rid of some of this business up here. In order to do that now, I'm going to have to get a common denominator on the left-hand side and then going to have to deal with one expression leaving that equal to 0 here. So what's my common denominator? Look, I'm going to tidy this up a small bit, right? Because I got x to the minus a half. That's, to start with, is a root x. And on top of it, it is underneath the line. So that is 1 over that is 1 over 2 root x. All right, so lowest common denominator between the pair of them is going to be equal to 2, 2 root x. Okay, now what does not 2 root x, don't be silly. 2x, that's more like it, okay? Because of course x doesn't go into root x, whereas root x does go into x. So if I had 1 over 2 root x and my new common denominator is 2x, what do I multiply 2 root x by in order to get 2x? I multiply it by root x. So there we go. That's my left-hand side sorted out. And then we have minus 1 over x. If our new common denominator is 2x, that's going to be root x minus 2. Now, I was looking to solve that equal to 0. So continuing solving that equal to 0, what's that going to end up making? All right. I should have put in a therefore as well. I'm getting a bit lazy now in my... So therefore, we've got root x minus 2 over 2x is equal to 0. I'm looking to solve for x. Okay, so therefore, when I multiply both sides by 2x, I end up with root 2 minus 2 root x, you big idiot. Root x minus 2 is equal to 0. And if root x minus 2 is equal to 0, therefore, look, root x will be equal to 2. And so, therefore, obviously, x is going to be equal to 4. Now, normally, we've basically found the point was 1, 2, 3, and 4. We've basically found the minimum distance between the two of them happens when x is equal to 4. We only found one max min point. We only found 1 point when we solved for x for the derivative equal to 0. But I can't assume, right? I would have to make absolutely sure that my answer here is correct. I'm going to put a little square around my answer now. You would be doing that on your page as well. And then we're going to quickly go back to the expression that we got for the first derivative. Okay, and the first derivative there was 1 over 2 root x. We're going to have to solve, we're going to have to find our second derivative. So if d prime of x was equal to 1 over, or let's do it the easy way. So that was 1 over 2 x to the minus a half. Okay, and we had minus 1 over x there. Well, then let's do our second derivative of x in that case is going to be equal to, so we're going to get minus a half times a half is minus a quarter. We're going to diminish that power again, so that would be x to the minus 3 over 2. And that would be, that was 1 over x. That's the same as minus x to the minus 1. So that would be minus 1, so plus, and x to the minus 2 this time. Okay, now let's see then what is, we have loads of therefores all the way down the side there. Let's see what d double prime of 4 is. Okay, that's what's really interesting me here. So that would be minus a quarter times x to the minus 3 over 2. So that would be 1 over 4 to the power 3 over 2. So that's the square root of 4 cubed. Okay, and then we're adding on to that. We're adding on 4 to the power of minus a half. So that is 1 over 4 squared. All right, let's do a little bit of calculation. That so root 4 would be 2. 2 cubed is 8. So we've got minus a quarter minus 1 over 4 times 1 over 8 plus 1 over 16. And basically the long and the short of it now, right, is that at this moment in time, I know that this number is going to end up being negative, okay? We can conclude here at this point in time, because we have a positive fraction being multiplied by a negative fraction. Without a doubt, that's going to mean that my second derivative of 4 is less than 0, if my second derivative of 4 is less than 0, then I definitely know that I am dealing with a minimum. Okay, so at this moment in time, having done all of that, and like I say, I would like to see that if I wanted to give full marks in this answer, I would want to see that somebody has checked and made sure once they found their 4 that they were definitely dealing with a minimum. Okay, so at the point that I get the second derivative at 4 is less than 0, I can then conclude, therefore, x is equal to 4 gives a minimum for d of x, okay? And this is, just to finish it, absolutely spot on, making sure that I get absolutely all the marks for it. And this is, and therefore, this is the minimum distance between f of x, or between f and g. They called it f and g up here, so we can call it between f and g. Okay, always last thing that I want to do in any question that I'm doing is make sure that I've actually answered the question. They said determine the minimum vertical distance between the graphs. I followed all the steps and I summed up by saying that therefore this is the minimum distance between f and g, and therefore I know that I am done and dusted. Okay, lads and ladies, I hope, as usual, that you enjoyed that little video. If you did, of course, send it on to your mates, send it on to your WhatsApp group for your back class. Make sure that everybody's got access to these so they can be doing some practice and getting a bit of a hand over the Easter holidays. I'll look to throw up another one of these in a day or two. So don't forget to like and follow so that that'll land into your feed. As well as that, if you're enjoying the videos, we have revision courses starting on the 12th of May. If that would be the kind of thing which would interest you, I'll throw up a link in our description or in the bio or something like that anyways, and that way you can get on to a revision course if you fancy it. Otherwise, good luck, enjoy the revision, and don't forget to look after yourselves. Goodbye for now, boys and girls.